Welcome back. Today we're taking a deep dive into Project Gemini, looking at its origins, objectives, and some of its major milestones. We've got quite a lot of written and video material to work with. Should build quite a comprehensive picture, I would say.
Oh, certainly. Project Gemini really served as the bridge between those first steps into space with Project Mercury and then, of course, the ultimate goal of Apollo, reaching the moon.
Yes, it's interesting, isn't it, that the idea of a two-man spacecraft actually predates Kennedy's famous moon speech? It was originally known as Mercury Mark II, but the concept was already being explored.
And of course, we mustn't forget the context of the Cold War, the nuclear arms race. It had a huge influence on NASA's decisions, didn't it? I mean, the development of solid fuel missiles like Polaris had a direct impact on their choice of the Titan II, as well as their launch vehicle for Gemini.
The Titan II, an intercontinental ballistic missile, had advantages with its hypergolic fuel, much easier to handle and store. But converting it for human spaceflight, well, that was a challenge to say the least.
Absolutely. And the program faced numerous hurdles right from the start, didn't it? Cost overruns, the infamous pogo oscillation issue with the Titan II, and of course the tragic death of astronaut Theodore Freeman during a training flight.
Terrible tragedy. These early challenges really highlight the inherent risks of pushing the boundaries of space exploration.
Indeed. And some of the design decisions were quite radical, weren't they, for their time? The decision to abandon plans for a Rogallo wing landing system and opt for ejection seats instead of the usual escape tower.
That certainly was a bold move, pushed by Jim Chamberlain, Gemini's chief designer. His reasoning was that because the Titan II's propellant wouldn't cause as large an explosion as the Atlas used in Mercury, ejection seats were a viable option.
Right.
I suppose he had a point.
But of course, the ejection system was never actually tested under the same oxygen-rich conditions as a real launch. So there were concerns about the potential fire risk, weren't there?
Quite a gamble, especially considering the later tragedies that underscored the dangers of pure oxygen environments in spacecraft.
Absolutely. But we mustn't forget the innovations either. Take the ballistic lift reentry system. That allowed for greater control over the spacecraft's landing point, a significant development.
It certainly proved its worth. But again, not without incident. The cracked faceplate on Gemini 3 was a stark reminder of just how unforgiving space can be.
Shall we look at some of the mission highlights then?
All right, let's start with Gemini 1, launched in April 1964. An uncrewed flight, of course. It served as a vital test of all the systems, evaluating the Titan II and the basic Gemini capsule design.
Intentionally destroyed upon reentry. A clear signal, wasn't it, of NASA's commitment to pushing boundaries and gathering data, even at the cost of the hardware.
Then in January 1965 came Gemini 2, another uncrewed flight, but suborbital this time. The focus was on the heat shield and reentry systems, obviously critical for the safe return of astronauts.
The initial launch attempt had to be aborted, just 1 second after ignition because of a hydraulics failure. You see, even with the most meticulous planning, these missions could be derailed by unforeseen technical glitches.
Absolutely. Always that underlying complexity and risk with spaceflight.
Right.
It wasn't actually until March 1965 that we saw the first crewed Gemini mission, Gemini 3, piloted by Gus Grissom and John Young.
A significant milestone, wouldn't you say?
Yeah, absolutely. America's first two-man crew in space.
It was a short mission, wasn't it? Just 3 orbits. But they successfully tested the maneuvering thrusters, proving that they could change their orbit for the first time, vital for future rendezvous and docking procedures.
And who could forget the smuggled corned beef sandwich?
Yeah, yes.
A little bit of humor.
Yeah.
It reveals the human side of these daring missions, even if NASA management weren't too amused.
Indeed.
Gemini 4, June 1965. Jim McDivitt and Ed White. The aim was to push the boundaries of human endurance in space.
4 days in space. That's triple the previous American record. And of course, the highlight, well, it has to be Ed White's spacewalk, the first for an American astronaut.
Iconic images, those, of him floating freely against the backdrop of the Earth.
We mustn't forget. This spacewalk was prompted by the Soviet Union's Voskhod 2 mission, which had featured a spacewalk just a few months earlier.
That space race.
Yeah.
Full swing, both sides constantly striving to outdo each other.
And that competitive spirit fueled a remarkable pace of innovation.
Yes, it did.
Yeah.
Next came Gemini 5, launched in August 1965. Gordon Cooper, a Mercury veteran, and Pete Conrad. Focus on endurance. spending a record-breaking 8 days in orbit.
Well, that duration was seen as absolute crucial, mirroring, as it did, the estimated length of a lunar mission, and it also marked a first use of fuel cells for power, significant technological advancement for longer, more complex missions.
Those fuel cells, though, proved to be a bit temperamental. They had to abandon their rendezvous practice with the rendezvous evaluation pod because of power issues. Resourcefulness prevailed, though. Buzz Aldrin, working in mission control, he devised a phantom rendezvous maneuver to salvage some of the mission objectives.
Clever. A real testament to the ingenuity and problem-solving skills required in space exploration.
And despite the challenges, Gemini 5 did achieve its primary goal. They demonstrated that humans could survive and function in space for the duration of a lunar mission.
Now, Gemini 6A, launched in December 1965, this was a mission that almost didn't happen.
Almost didn't happen.
The initial plan was to rendezvous with an Agena target vehicle, but then a launch failure forced a dramatic change of plans.
Oh dear.
Yes. But in a remarkable feat of adaptability, NASA decided to use Gemini 7, which was already in orbit, as the rendezvous target.
Bold.
It was. Wally Schirra and Tom Stafford on Gemini 6A successfully rendezvous with Frank Borman and Jim Lovell on Gemini 7. It marked the first ever rendezvous of two crewed spacecraft in history.
Absolutely historic. And of course, we mustn't forget that Gemini 7, while acting as the rendezvous target, also set a new endurance record. 14 days in space, that's longer than the planned duration of the Apollo lunar missions.
Remarkable.
Testament to human resilience and the reliability of the spacecraft's life support systems.
Now, Gemini 8, launched in March 1966, aimed for another groundbreaking achievement: docking. Neil Armstrong, on his first spaceflight, commanded the mission, with Dave Scott as the pilot.
A mission that began with triumph, but sadly ended in near disaster.
They did successfully dock with the Agena target vehicle, but shortly after, a thruster malfunction sent the combined spacecraft into a terrifying spin.
It was a stark reminder that spaceflight is inherently perilous, wasn't it? However, Armstrong's quick thinking and piloting skills averted catastrophe. He regained control using the re-entry control system thrusters.
A very lucky escape.
They had to make an emergency landing in the Pacific, cutting the mission short, but the experience provided some crucial lessons for future missions, highlighting the need for redundant systems and robust emergency procedures.
Absolutely. Every challenge faced, every lesson learned paved the way for future successes in space exploration. So next up we have Gemini 9A, launched in June 1966. This one was intended to continue those advances made with docking procedures.
Right.
Tom Stafford and Gene Cernan, they were tasked with rendezvous and docking with an augmented target docking adapter, or ATDA.
Ah, yes, the ATDA. A crucial objective, I suppose, in mastering the rather complex maneuvers required for the lunar missions.
Precisely. But unfortunately, the mission encountered a bit of a setback when the ATDA's protective shroud failed to fully separate.
Yeah.
Made docking impossible, of course, so they had to adapt their plans.
Resourceful as always, though. Despite that setback, they still managed to rendezvous and fly in close formation with the ATDA, gathering valuable data on those close proximity operations.
Indeed. And Cernan, he also conducted a 2-hour spacewalk during this mission, but he encountered quite a few difficulties with movement and overheating.
Yes. A clear reminder of the challenges of working in a pressurized suit in the vacuum of space.
It did provide some essential lessons for future extravehicular activity missions.
And I believe his experience led to some modifications in suit design as well, didn't it?
It did. And improved training protocols for astronauts too, of course.
The pursuit of space exploration really necessitates constant learning and adaptation.
It certainly does.
So, moving on. Gemini 10. Launched in July 1966. John Young, now on his second spaceflight, as commander, and Michael Collins as the pilot. They pushed the boundaries of orbital operations even further.
They really did. Achieved a rather remarkable feat, rendezvousing and docking with an Agena target vehicle, and then using the Agena's propulsion system to boost themselves to a higher orbit.
Fascinating.
A technique that would, as you know, prove vital for the Apollo mission.
Yes, of course. This innovative approach really demonstrated the potential for using docked spacecraft to extend mission capabilities and reach new orbital heights.
And Collins also performed 2 EVAs during this mission. He retrieved a micrometeorite collector from the Agena. It was a historic first. The first time a human had made contact with another spacecraft while in orbit.
A significant achievement showcased our growing ability to interact with and potentially repair objects in space.
Indeed. Building on these successes, Gemini 11, launched in September of 1966, this time with Pete Conrad commanding and Richard Gordon as the pilot. This mission, they set a new altitude record.
They did. They reached a remarkable 850 miles, again using the Genus propulsion system, enabling them to study the Earth's magnetosphere and gather valuable data on, well, radiation levels at high altitudes.
And that data was, well, it proved invaluable in assessing the risks and challenges of prolonged space travel, especially for those future lunar missions.
Yes, of course. Gordon also conducted an EVA during this mission, and I believe he experienced similar difficulties with the suit and fatigue as Cernan had on Gemini 9A.
He did, further emphasizing the need for those ongoing improvements to EVA systems and training.
Each mission brought new insights, pushing the limits of human endurance and refining the technologies and techniques required for venturing further into space.
That's right.
And then finally we arrived at Gemini 12, the last mission of the program, launched in November 1966. Jim Lovell on his third spaceflight commanding, and Buzz Aldrin as the pilot.
Now, Aldrin, renowned for his meticulous approach and expertise in orbital rendezvous, he was absolutely determined to address those issues that had plagued previous EVAs.
He certainly was.
And he succeeded admirably.
He did. During a record-breaking 5.5-hour spacewalk, he demonstrated the effectiveness of working outside the spacecraft with proper handholds, footholds, and restraints, really paving the way for the complex extravehicular activities crucial for those future lunar surface operations.
His achievements were, well, instrumental in dispelling any concerns about the feasibility of those extended and complex EVAs. It marked a significant step forward in human capability in space.
It certainly did. You know, looking back at Project Gemini, it's evident that it achieved far more than just a series of test flights. It was a period of intense learning and development, bridging the gap between those early space flights and that ambitious goal of landing on the moon.
It was a program that not only advanced our technological capabilities, but also, importantly, expanded our understanding of the physiological and psychological effects of prolonged space travel on the human body.
Yes, that knowledge, gleaned from those long-duration missions, was absolutely instrumental in preparing for the challenges of lunar exploration and shaping future approaches to human spaceflight.
We've seen how each mission, from those unmanned test flights to the record-breaking endurance and altitude achievements, built upon the lessons learned from their predecessors, constantly pushing the boundaries of what was possible.
The emphasis on rendezvous and docking procedures, the development of fuel cells for power, the refinement of EVA techniques and equipment, all these advancements played a critical role in laying the groundwork for the success of the Apollo program.
Absolutely. But beyond the purely technological advancements, Project Gemini also played a crucial role, didn't it, in the development of the astronaut corps?
Right, providing invaluable experience to the individuals who would become key figures in future missions.
The likes of Neil Armstrong, Buzz Aldrin, and Jim Lovell, to name just a few, they honed their skills, they gained crucial experience during those Gemini missions.
Individuals shaped by their experiences in Gemini went on to become household names, embodying the spirit of exploration and pushing the boundaries of human achievement.